Okay, this is Mr. Peterson, and we're on the final installment for this part of the review, 3.1 through 3.3. If you're in Honors Algebra 2, there's another section, 3.4 and 3.5, that will come later. Okay, so factor each polynomial completely, and some of them, probably most of them, have a greatest common factor, and you should always pull that out first. I've trained you that if you're going to do this, if you have a negative up front, you want to pull out the negative version of the GCF. And both of these are divisible by 6, so I'm going to use a negative 6 for my GCF. When you do that, you get, let's see, 4x squared minus 1y squared. And at this stage, you're looking at a difference of two perfect squares, so this breaks down with a plus and minus sign. Two x times 2x will give me the 4x squared, and y times y to get the other one. And that, ladies and gentlemen, is one nicely done problem. It's finished. Okay, on this next one, we have a common factor of 3x squared. We can pull a 3 out of all three of those terms and an x squared out of all those terms. So pull the 3x squared out. You get 4x squared minus 4x plus 1. And what we have on this trinomial here is perfect squares on the ends. So this is probably a perfect square trinomial. We're going to try it. Okay, on these problems you want to use the middle sign both times, and to get this it's 2x times 2x. The back half is a perfect square that's 1 times 1, and we're going to check and make sure the middle term turns out. I see a minus 2x there and a minus 2x there, which is minus 4x. So we're done, although this one could also be written alternatively as 2x minus 1 squared. So this is fine, but you can write it this way also. Okay, what's dead giveaway about this one is we're dealing with 1, 2, 3, 4 terms, so we're going to go two groups of 2 terms. And then you pull out your common factor. In this case, it's 3x to the third. And you get an x minus 2 there. And then on the back half, you start with a negative sign. Whatever sign is right there, you copy. And we're going to pull out a 9x, which gives us x minus 2 there also. So now we're going to pull out the x minus 2. And that gets us down to 3x cubed minus 9. Now, this is really problematic. I could have pulled out a 3 up there, another 3 up there. Let's see here. Anyway, there's a common factor of 3 here that I have to pull out. So I'm going to pull that out, and I get my x minus 2 there. But when I pull a 3 out of this, it becomes x cubed minus 3. And that, ladies and gentlemen, can't be factored any further, so it looks like we're done here. But I'm going to double check this. So I will type in 1.23 or some number of your choosing, and then I'll type the original expression. So that turns out numerically to be that value, and now I'll type the bottom expression. And we get matching values, which lets us know that we did our work correctly. Or at least we haven't made a mistake. You can imagine checking this line, and it would check, but you really hadn't finished the problem because there's still a common factor there. Okay, so I could have pulled that 3 out, by the way, at the very start of the problem, and I didn't notice. Okay, so this next one here, we're going to divide all 3 of these by the common factor 2, or we're going to pull that 2 out, actually. So when you do that, you get 16x squared plus 24x plus 9. And at this stage, you look at these perfect squares on the end. You say, I'll bet that's a perfect square trinomial. So you set up two parentheses. You use the middle sign. Happens to be a plus. And then you put your perfect squares, your square roots in. 4x times 4x to get that one. 3 times 3 to get the other one. We're going to check the middle term. 12x right there. Another 12x right there. That works. So you could write this one like this. 4x plus 3 times itself could be written as squared. Okay, on the next one here, the common factor is 3x, but we have a negative in the front, so we want to pull its negative version out. Once you do that, you're dealing with a difference of two perfect squares, so we want a plus sign and a minus sign on the next line. 2x times 2x, that would get the 4x squared, and 1 times negative 1 to get the negative 1 up there. Okay, now we're ready for this next one, and it's got a common factor of 2x, and I'll pull that out in a minute, but it does have a negative sign in the front, so I want the negative version of that. So I get 27x cubed plus 8. And this, ladies and gentlemen, is called a sum of cubes. And it's that SOAP formula that we learned earlier. So we're going to write this a little differently. We're going to write it as 3x to the third plus 2 to the third. And now you're ready to put it in. Negative 2x, you'll use a short parenthesis and a longer one. You put your 3x in and you square it. You put your 2 in and you square it. And for the middle term over here, you multiply 3x and 2. Then you put some SOAP on it. Same sign as the original, opposite sign, but back here always positive. And we have one more step here to do. We need to check this answer, so I'm going to take 1.23 and store that for x. Probably didn't need to do that since this calculator had that done a minute ago. I'll type the original. So here's the original problem. And I'll type this answer down here and see if it agrees. And what do you know? We got agreement there. That's good news. Okay, so that does it for these help videos for sections 3.1 to 3.3. And I'll probably make some more for you guys if you're in Honors Algebra 2 doing 3.4 and 3.5.